This is Jim Morentz, the XchangeCore community, and today we're going to be talking about interoperability use cases that will improve emergency operations. And we're going to do that by taking a look at how use cases are used and then go through 5 different use cases. Going to talk about how to filter dispatches to avoid cluttering in incident management applications and how to get the right information to the right responder at the right time, and how to organize a variety of different private sector information from companies or from CERT organizations or shelter management organizations, and how to selectively pull that information and put it into the right common operating picture or even out to a public website. We'll talk about how to match infrastructure data to suspicious activities for intelligence analysis. And then finally, how to create a two-way flow of information. So you're gathering information out of a GIS, updating it with field observations, putting it back into the GIS, and then sharing it out to everybody else so that everybody has the updated information. And then we'll open it up to discussion about this topic or any topic at all. So how about if we get started? First of all, why do we think about use cases? Well, that's because they're a nice way to break actions into a logical set of steps. In particular, when you're talking about how humans and technologies interact. And use cases are used on 2 different levels. One, software systems engineers sit there and do complex diagrams to convert what people want into what they end up building. Then when the technology is there, managers and operators can employ these kind of use cases to see how the software itself may apply to their own needs or may change the way in which they manage operations. So in short, the role of a use case is to tell us how best to use technology. XchangeCore use cases have a couple of very specific roles. The first of which is to help match those capabilities that are inside of XchangeCore with the needs that any organization has, whether it's public sector, private sector, military, government. XchangeCore has capabilities. What do you do with them? That's the first reason to use a use case. And then it really becomes a brainstorming opportunity. All right, so I got a bunch of needs here. Well, how am I going to specifically apply XchangeCore, information exchange, to this set of needs? If you already have an XchangeCore implementation, sitting down and going through new use cases may expose you to new functionality or new technologies that you can bring into the XchangeCore implementation. But probably most importantly, for those of you who are looking at this as a way to get started or have a specific problem, it's how to get a quick win. I've always said that one of the most important steps that you ever take in thinking about any kind of information exchange or even any kind of technology is to get a quick win that helps show everybody the benefits of what you're doing. That's the way you get buy-in to a technology operations, deliver benefits. The best way to do that is do it quickly, at low cost, low level of effort, so people aren't sitting there saying after 2 years, gee, how's that technology coming? Rather, after 60 days, they're sitting there saying, wow, I was never able to do this before. That's the role that these use cases have and how we're going to show you how to perhaps borrow some of these ideas into your own application. So let's start out. First one is CAD, computer-aided dispatch, to CIMS, a crisis information management system. That's a WebEOC or an E-team or a spot-on response or any of those tools. And a common operating picture. So we've thrown all those acronyms out there. Dispatch, incident management, and common operating picture. And the most important piece is how are we going to gather and then selectively distribute that dispatch information. Because, as this use case begins, Dispatches have different audiences for different purposes. Clearly, if I have a police dispatch, police is my number one audience. Those officers out on the scene who need to understand where to go and what to do and how to respond. But fire frequently ends up, emergency medical services frequently end up at the scene of an automobile accident. A coordination is necessary. As a result, the first look at this use case is that we have a common operating picture. That is the way that police, fire, emergency medical service get a common view and see all of each other's dispatches, so that there's police support for a fire, or EMS arrives appropriately at an accident scene, or a fire that's handled by fire can make use of EMS resources or police resources to provide a secure area around the scene. So this requirement to bring in dispatches, and it is not uncommon still for there to be a fire dispatch, a police dispatch, and a medical dispatch. More often medical and fire are gathering together, but very frequently, even if you're using a common technology, it is not common for every police dispatch to be seen by fire because police have very sensitive dispatches sometimes. So the way to pull those three different streams of information together is to create a common operating picture that all police, fire, and EMS can see. The second part of that use case, however, is different because now I'm an emergency management agency. This emergency management agency is looking for EOC situational awareness using its crisis information management system. And in that crisis information management system, I want to see things that are of multi-agency importance, or ones that are going to have to allocate resources among both public safety agencies and second response agencies, or incidents that spread resources across more than one jurisdiction. So I'm only going to want to see things that are done by police or fire or EMS that meet my criteria for understanding what needs to go into my EOC, which is not every single traffic accident. The third part of this operational use case then is many, many jurisdictions, and eventually I would say almost every jurisdiction, is going to end up with a public website that is able to show what's going on in the community. But you're not going to want to show them everything that is happening in police, fire, and EMS. You may not even want to show them the same thing that is happening in an EOC. Rather, you're going to want to select certain dispatches that are appropriate for general information. Where traffic accidents impede traffic, that's a public access and publicly important piece of information. Heck, I can get it on Google Maps now. So why should a government not be supporting that activity? If I have a multi-alarm fire that is also going to affect traffic, but perhaps have an area of concern around that fire for smoke inhalation for old people, I would like to put that out on my public website. So this use case calls for sharing among first responder agencies, everything, sharing specifically to emergency management, those things that are of EOC importance, multi-agency or multi-jurisdictional, and to the public, just a little bit that's important to the public. So let's see how this unfolds with XchangeCore. Now in the bottom left-hand corner, we have many types of dispatches, as we just talked about. Those get processed to XchangeCore. XchangeCore creates that dispatch, turns it into a NIEM incident work product, the National Information Exchange Model definition of what an incident is, into an XchangeCore work product. XchangeCore then notifies all the applications that are connected to it that we just had something happen. And you may be able to look at it. As we said earlier, number 4, the Crisis Information Management System only wants to consume one type of a dispatch. The public website is allowed to only get selected dispatches, and the public safety cop wants all the dispatches. So the process that unfolds then looks a little bit like this. Still have all the dispatches coming in on the left-hand side. Number 7 down there explains how the virtual cores in XchangeCore allow you to have that dispatch connected to one virtual core, the other virtual core being connected to other applications, and the exchange that takes place between the two virtual cores is based on agreements and rules that allow filtering of the dispatch by the what type, the incident type. So I can go in and I can say, I want to only see incidents of a hazmat, or I only want to be able to share out the specific traffic accidents that don't involve any injuries because I don't want to run the risk of slipping in and exposing any HIPAA information. So I can write those rules between two virtual cores, which allows on the right-hand side, number 8, my EOC to only get one type of dispatch, or the selected types of dispatch that it chooses. And where we've done this in a couple of places, you have all of your dispatch codes, usually obscure ACL and things like that, that are coming in on the left-hand side. And we use those codes to create a consumer on the right-hand side in the EOC that says, I only want to see an ACL, I want to see an HM, I don't want to see a PS1. And you build that table of what you're going to move from one virtual core to the next virtual core. Public website, exactly the same thing. You're going to feed information out from a virtual core that only has certain types of information in it. And then finally, number 10 up in the upper left-hand side, I don't need to filter anything. I'm going to share everything that comes in from one or more of my CADs out to the common operating picture that's being used by all of those first responder agencies in order to manage their emergency response. That's use case 1, where we took a look at how I'm going to take highly critical information from my dispatch and put it into the hands of the right people to be able to get them that correct information at any given time. So let's go on. Let's take a look at the next one. This is how I want to get the right incident to the right responder by agreement again. Our operational use case begins with a broad statement that incidents have consequences for different jurisdictions and different agencies, and yet have no consequences for others. So this is an extension of the one that we just talked about, because I want to now share information by not just that what category, but I may have a regional emergency management operation going on, and I want to share an incident information to specific EOCs based on their jurisdictional responsibility. Second component of that, I want to share information about a specific thing, a wildfire or a medical response or an environmental, based on the content of the incident. So we're only going to put to the wildfire agency wildfire information. And then the third thing, I want to be able to filter all this different information that's coming in from all these different organizations. I want to orchestrate it together, filter it out, so that I'm only going to send, for example, to the state EOC, just things that are high severity incidents. Or maybe it's the state toxic spill response agency. I want to send to them things that are just related to hazardous materials accidents. And the reason for doing this in this use case is to selectively gather the information and distribute the information, first to avoid information overload. Don't want to see every accident, traffic accident in Washington, D.C. when I'm sitting out here in Maryland. Secondly, I want to be able to protect sensitive information, like we talked about earlier, police information that's sensitive, certainly anything on a medical nature. I only want to get that out when there is something critical. And then finally, I want to be able to focus the response to the appropriate response organization. If I can do that using XchangeCore, I'm alleviating the need to do that out on the edges, with the end users, with the applications, with the managers who are in EOC, or the manager who is inside of a dispatch center. They're not saying, hey, forget about this one, don't think about this one, I don't care about this one. That one's too far away for me to respond to. Those are all the ways in which you can use XchangeCore to speed decision making. How that happens, technically, is as follows. I've got an application over there on the other side, and that can be multiple applications as well. And it has many incidents. And on the right-hand side, there are many subscribers, all of whom have different incidents. So all that information from one or more applications on the left-hand side gets sent to XchangeCore. What XchangeCore does is create the incident work product and evaluate against agreement rules for each of those subscribing applications. On the right-hand side, we see those subscribing applications, and one says, hey, my rule says only give me wildfires. The second one says, my rule says only give me ones that are within 5 miles of me. The third one says, I only want to see things that are extremely bad. So what we've got then, again, is using the ability of XchangeCore to build these virtual cores. So each application on the left-hand side and the right-hand side is going to have a virtual core within a single physical core. That means you got one server out there, but you're using XchangeCore to partition it up so that everybody has their own set of rules and the own ability to connect different applications to that virtual core and obey those rules. So number 7 says each core is then going to exchange information with the other cores based on those rules. So left-hand one can send something to the top, get something from the one in the middle, share back and forth with the one on the bottom, and if it's a different thing, it's not going to share it to number 2, it's going to share it to number 3, etc. So you can build those rules in a very, I'll call it, complex but easily done fashion. When a work product arrives at the core, the applications are notified, which results over there on the right-hand side now of, by matching incident types to the interest, the one up in the right is going to get A and D. I think we asked for wildfire, so this may be a wildfire coming from a jurisdiction A, a wildfire coming from jurisdiction D, but they're both wildfires, so they have made it through the rules and end up showing on the person who says, I'm interested in wildfires. Where my core is says, okay, I only want things within a certain distance. And the one in the middle there, C and D, well, it turns out that C and D are within, pick a number of miles that somebody has identified, of that core location. So I'm only going to address ones that are of interest to me. C, down at the bottom, turns out also is a severe event. So for the organization that is looking only for event severity, or is looking for event severity in addition to some other combination of criteria, C is going to show up down there. So by doing this, we've taken one application or multiple applications on the left-hand side, used the virtual cores, built rules, and are able to then segment out to all those different organizations and their applications exactly the kind of information that they want to have. All right, this one. This really derives from Craig Fugate's idea of as the direct administrator of FEMA, of a whole community having to respond to the emergency. This is brought into play over the last few years since this has been promulgated by FEMA. The idea that there are many non-emergency organizations that contribute to emergency response. Yet if you think emergency response can be pretty chaotic, you can imagine what it is when you have non-emergency organizations participating in that emergency response. They lack coordination. Coordination shouldn't have to mean telling every organization what every other organization is doing. You should be able to have an XchangeCore that helps to orchestrate the information, as we've seen in the previous two, by a number of different ways, so that the non-emergency organizations can pay attention to their own recovery and get only the information that is relevant to supporting their own recovery and the community recovery without getting extraneous information. Because quite frankly, and those of you who have participated in any of our webinars jointly held with SABRE, the Single Automated Business Exchange for Reporting, you've heard Walmart and Walgreens and others say their number one job is to get their store open because that's how they support the community. So if they have tasks that are being assigned to coordinate with other agencies that take them away from reopening their store and supporting the community, then the whole community is not doing a service, rather it's doing a disservice to the community. So XchangeCore is a way to carry out that coordination without imposing the information requirements on those non-emergency organizations. For example, shelter organizations, principally the American Red Cross, but in coordination with the school that is using or the Elks Lodge that the Red Cross is using, as well as independent shelters that represent a substantial number of shelters across the country that are supported and inventoried, maintained by the states themselves. So shelter organizations, they should be able to report their shelter information internally to their organization. So Red Cross report to Red Cross. If it's a Salvation Army and in feeding locations, they should be able to report to themselves, doing only what they need to do, and technology should be able to coordinate that information elsewhere. It's especially true, and that's what the role that SABRE organization does, is to help private sector companies report their status one time into SABRE, which has XchangeCore as its base. And then many government agencies can be the recipients of that information. And a Target or a Lowe's doesn't have to worry about 50 organizations asking them for information. They know that those organizations, as members of SABRE, are getting all the information that they're providing to SABRE. The result of this use case is that all the organizations are getting the same incident-related content. But most importantly, because it's going through XchangeCore, you can be absolutely certain that that content is current, that it's simultaneously available to every organization that's associated with it. So you don't have one fire department acting on information that another fire department has not yet received. It's continuously accessible. It stays in XchangeCore and is available on demand. So anytime another organization joins in the response, a more distant fire, to continue using that example, a more distant jurisdiction provides their fire services, that distant jurisdiction can access XchangeCore and get the same information that had been previously published out to everybody else, but they can get that same information. And then finally, because it's XchangeCore, basic capability is that it gets translatable to every organization's software. So you're not sitting there saying, gee, I got a spreadsheet, now I need to take this spreadsheet, I'm going to try and find the right columns and plug it into something else and put it up on Google and do It's all there. It's all available in all the different formats that XchangeCore provides. So that's the use case. Let's see how it works. It could work this way. It would be a shame, and it does work this way. But over on the left-hand side, you've got the status updates that are requested from businesses or shelters or volunteers by, on the right-hand side, many different organizations who want to use that status in their own COPS or CIMS or other applications. And that results in something that looks that silly. The top left one is going to send it to the top right one, the middle right one, the bottom right one. And they're probably sending it because the three on the right sent an email or made a phone call to the top left one and said, hey, gee, could you give me your information? Huge, huge waste of time, which is replaced by the ability of anybody on the left with those 4 different kinds of information that are represented there to do a spreadsheet, to make an electronic feed, to have their application connect directly into XchangeCore. Thus, many, many different kinds of formats. Go into XchangeCore, and the status inputs are then transformed into NEEM-compliant work products. And on the right-hand side, all the different applications consume the status information from those many different organizations on the left-hand side. Any COP, any crisis information management system is going to be able to get that in the format that they need. And on the right-hand side, you have all the information from the left-hand side, represented by all those different little blue symbols, represented currently, simultaneously available, there on demand, and translated into that application requirements on the right-hand side. We've taken human beings out of a huge, burdensome part of maintaining situational awareness. And XchangeCore was built exactly to do that. So, we talked a little bit about GIS, these last two. I'm going to use GIS as an example, but any type of incident management software will benefit from this. And this first one grows out of a project that we're doing right now with one of the states where they have GIS data, and it's contained in many, many different systems. And it's generally static data, infrastructure layers, and it changes only occasionally throughout the year. It's not often that you're going to get lots of changes, and certainly during the confines of an emergency, you're not going to see the number of occupancy in a industry or a chemical company that's going to change a production that's going to make a difference during that emergency. So you've got all that, what I consider sort of background infrastructure information. But that information really becomes of highest value for emergency management when it's specifically associated with the spatial impact area of the incident. So I have a traffic accident. I may only care about things 1 block around that traffic accident. Do I have a school that I don't want to release at this moment because I've got a bunch of police cars and ambulances half a block away? If that traffic accident happens to have a hazardous materials associated with it, that area of interest might extend to 2 or 3 miles. So managing the relationship between the impact area of an incident and the static layers of infrastructure creates value. The second part of creating value is when that result, I have an accident here, or I have a fire here, and here are the infrastructure that might be impacted, the schools, the hospitals, the nursing homes, the other industry, the utility lines, all of the other components. If that set of information is then shared to the widest appropriate audience of response decision makers. So if I've got that hazardous materials accident and I need to share it, and I just share it to the police and I don't share it to public health that can then warn those nursing homes of an inhalation danger, I'm not doing my job. And when you have to do all that manually, remember every one of those steps, that's where emergency response has more difficulties. When these GIS applications are notified of an incident then, the application must interpret the location, the area of interest, and the content that will be useful to the response. So, if I've got that hazardous materials incident and it is the middle of winter and I have a swimming pool, I'm probably not going to care. So I need to be able to understand what that infrastructure is in my community, match it to the needs of the response, and create utility for that content. So again, I'm not overloading information. GIS information then provides that relevant information back to the originating application and any other relevant application. And the result of that is, the benefit of it is, that rather than having an application being forced to discover what's useful or sorting through layers and layers of GIS data, the response gets the data necessary to make good decisions in an instant. The case where we're doing this now looks something like this. We got an application on the left-hand side, and it provides a location of interest or an area of interest. Now, in particular, we're working with suspicious activity reports. So it could be an accident, or it could be a business address where I've got a robbery going on. But in this case, suspicious activity report. That gets sent to XchangeCore, where the incident work product is created, applications are notified, and the application, the GIS application in this case, consumes the location from the incident work product. Next step then is, on the right-hand side, the little red flag there indicates that we have taken that location and we're providing all the relevant GIS data associated with it. Location, we have an area that we decide. This is a traffic accident, so I'm going to look for 500 meters or whatever. This is a hazmat. I'm going to do a plume model and do a buffer around the plume model and give you all the information there. And that data then gets associated with the incident work product. So back in XchangeCore, these things are all going to match up. So whether it's critical infrastructure within a distance of a point, or it's homes that are within a buffer around a flooded area, whether it's nursing homes and hospitals that are in a buffer around a hazmat spill, all that information then gets returned back to XchangeCore associated with that first incident, that green dot that started over on the left-hand side, that location. XchangeCore is going to take that incident work product with this new information and update it, associating the GIS data with it. And that then gets notified and sent back to the originating application that then has a work product that contains the specific information that it cares about. I'm talking about GIS data right now because that's our example with the suspicious activity report. They're going to be able to view and use and process the fact that there is a chemical plant near the suspicious activity report, and there's a nursing home near it, and there's something else, some of which are relevant, some of which aren't. But the analyst sitting in front of that left-hand application is very quickly able to say, I have this person who's doing something odd here that was reported. Let me check and see whether there's anything nearby that we care about. And if I do that 3, 4, 5, 500 times, I can start to begin to say, we've got this person, and 4 different times he's been near a chemical plant. That's how to turn fragments of information into intelligence by using XchangeCore to orchestrate that data. As well, it doesn't have to be GIS data. I could use emergency planning information, for example, and be able to provide that information back to the originating application. We'll take a look at how some of that can be extended in our next use case. So this is how we want to create a two-way exchange of information that allows us to dynamically update those static data layers. And we're working on this in another project where people are using the Homeland Security Infrastructure Protection database that is updated periodically, and only certain portions of it are available at a more general level. It's really a federal database, can be used under certain circumstances by states. The HCIP database, though, has a version called HCIP Freedom that is more generally available if you have reason. But hasn't been updated for a while in a lot of instances. So this is going to show us how we can build on this static environment that's contained in the GIS with both field observations and analysis from other applications in order to improve decision making. Some of the reasons you want to do this is to assess the potential impact to people, infrastructure, and the environment, sort of like what we did before. To estimate the resources necessary to combat the incident and to assess whether there are potential secondary effects of cascading incidents. So extending that ability to say, gee, around this problem area, here's some infrastructure. Now we want to say, okay, here's the infrastructure, but let's monitor it. Let's see how it changes. Let's continue to observe it. So not just the static layer, but building a dynamic exchange of my incident and infrastructure and other related information. So the way this unfolds is once the GIS data is associated with the incident, information is provided to other applications, just like we did earlier, viewed, analyzed, improved. But now that improved data is going to go back, update the original data, changing the status of an infrastructure, or maybe even just the occupancy of a shelter. And any other application is then going to be able to get the benefit of those changes and see the updates to that information without having to do anything smart or difficult or be notified or have any additional work on the part of anybody. It just creates this constant flow of decision support information. So let's take a look how that happens. We'll clearly flow through these next several slides. First part, just what we did earlier. Application is going to provide an incident to the incident work product in XchangeCore, which creates the incident work product, notifies other applications, and on the right-hand side, that application is going to get that location from the incident work product. Now, that application is then going to identify the relevant GIS data just like we did. But this time, it's not going to update the incident work product and send it back to the original application. This time, it's going to begin to create this two-way flow of information. And it does that by publishing access to that GIS data, not moving the data, saying here's a nursing home at this latitude and longitude, as we did in the earlier example. It's saying here is the access to this actual GIS data that is sitting on my GIS server. Obviously, you've got permissions. You need to know who your recipients are, but that's all taken care of with what we're going to talk about now. So the application publishes access to that red flag in there, and it does that in the little gray table there representing a piece of paper in the Open Geospatial Consortium Map Context document. That is the XchangeCore standard for discovering dynamic GIS data, which assures its currency, makes certain that everybody's looking at exactly the same thing. So what you have now in that little gray looking piece of paper thing is the web access information to the GIS data that's in that little red flag there around the incident. Next step then is that the application down the bottom right-hand corner uses the access to that GIS data, which is really just a URL, just like you would type at the top of a browser that's in that map context document. And it goes off to that server and it says, may I have this data? And if that server says, yes, you're authorized to get this data, that data then flies on back to this application on the bottom right-hand side. And I now have consuming in this application the GIS data directly from the source, making certain that the integrity of the data, and we've also made certain of the security of that data, because that application in the upper right-hand side requires authentication, which has been done in this process. So now, down on the bottom right-hand side, I've got the GIS data from the upper right-hand side, and we're going to do something to it. We're going to say, hey, you know what? This data is wrong. You've got this list of chemicals, let's say, as being present here, and lots of sources of coming out of SARA Title III from years ago, a list of all the hazardous chemicals that are at this site. Well, somebody consumes this and says, you know what? I don't have that chemical anymore. I need to have this information updated. Or I have a building that's no longer there that has been taken down. Whatever the change is, I can now submit back directly to that server in the upper right a correction or a change or an addition to that original database, which, given the right permissions, will process inside of that geodatabase as an update to the database. That takes us to having new information. Now, what happens with that new information? Well, other subscribing application use that same map context document that we all got earlier to request and consume that same information, the updated dynamic GIS data. Everybody across the bottom has now said, gee, I'd like to have that information. Well, not only do I get it by using the same map context document, I am getting it with the changes that took place from that changing, bottom right-hand corner, GIS that added the blue dot in the upper right-hand corner. So everybody now has the same information at the same time that has been improved in a two-way flow, thus turning that static GIS layer into a dynamic layer that is being improved by any one or now perhaps all of these different applications. Again, all securely done through authentication back at that original data owner, thus providing for us the ability to go right ahead and deliver all of the different types of information, improvements, and growth in the quality of that information that is necessary, as we've shown through each one of these, to make those who are responding to the emergency better informed about the available information in order to make the right decisions throughout their emergency response. That's the whole role of this set of use cases. This is to show you how disparate information becomes common, orchestrated through XchangeCore, and then shared and available to those who need to make the right decisions. So with that, let me stop, open up the microphone, and see whether anybody has any questions.
Yeah, you said it's compatible with other types of software. If an agency is already using like WebEOC or Active 911, et cetera, I assume it's compatible with what they have currently?
Yes, exactly. XchangeCore is the data in the background. So either they already have built a connection to XchangeCore and it's there and available, or you build a connection to it and the first time and then can share it to all the different users of that particular software.
Okay. And a little bit about security, in transit as well as data storage within XchangeCore, how security is managed?
This is a HTTPS, a secure socket layer application, so it's exactly the same thing your bank does during the in-transit exchange.
So it's like TLS?
Yes.
Okay. And as far as, does it store any data there within the XchangeCore application itself? And if it does, how does it keep that secure?
Yeah, that depends on who's running the XchangeCore. It's as secure as that network is. XchangeCore has been certified to operate through a DIACOM authority to operate on the .mil networks, and has also been through the security review by Department of Homeland Security to operate on secure .gov networks. So it depends where the XchangeCore goes, which can be hosted or it can be stored locally. So that's up to the end user.
Does the XchangeCore itself natively have any security, or does it store any data, or is that necessary to have its own native security?
Yeah, it does store its own data only while the incident is going on. At the conclusion of an incident, everything gets automatically deleted off of there, and we rely, the database itself is not encrypted unless the end user who owns the database wants to encrypt it, but XchangeCore does not. Its native release does not do encryption.
Okay. Is it compatible with different types of database? So if an agency or has some kind of database they're currently using, could XchangeCore tie in with what they're currently using as far as like SQL or something like that?
Yep, exactly. It uses a SQL database, and the one that you choose to plug in is entirely up to the end user.
Okay. So in essence, it can be encrypted if they happen to have a SQL instance of their own that they've decided to put some kind of third-party encryption software onto?
Yep, exactly.
Okay. I guess last question is, have you gone through the FedRAMP review for this?
FedRAMP is the authorization for access, and what would go through a FedRAMP would be a internet service provider, for example. When you go after you get through the access, we've been through the accreditation to operate on those servers, but FedRAMP's a slightly different accreditation. So no to that, but yes to individual certification and accreditation on both the .mil, specific .mil network and a specific DHS network.
Okay. That's something we can work on then.
Yeah. Yeah.
Okay. Thanks.
Well, let me wish all of you an excellent couple weeks until we get together again. We've got a couple of interesting. Next one may be a good technical session on moving, obtaining from XchangeCore GeoJSON data. That'll be either next time or the one after that. So watch your XchangeCore update newsletter and have a good few weeks, and we'll talk later. Thanks, everybody.